All right, so this is going to be 1.2a, which is objectives 1 and 2. Calculating measures using the betweenness of points, which we saw in a lab, and identify, apply, and create congruent segments. Before we do this, we're now moving into our first really math-based geometry objective when it comes to calculations and problem solving. So this is the convergent thinking geometry problem solving procedure that we need to follow. The first test, 50% of your grade is based on these 2 points. 25% is based on these points. And the last 25% is based on having the correct answer at the end. All right. I have had students turn in tests with all of the correct answers and nothing else, and they earned a 25% on their test. And I will have no problems doing that. I am ruthless. You need to show all of these steps. And I'm going to show you exactly how to show all of these steps, and it's an open note test, so there's no excuse to not show all of the steps. All right, so here are our steps. First, describe the relationship in words. In words. Next, we're going to write the equation. Sometimes this is specifically a formula, but the equation for the relationship. And we need to include both sides of the equal sign. Too many times I see students just write an expression. Carmen had me in algebra last year. I'll delete this part from the video. But an expression is only 1/2 of an equation. To have an equation, we need an expression on each side and the equal sign in between. All right? Without an expression on each side, we do not have an equation. We have not gotten that 25% for having an equation. All right, we're going to identify and label our known variables. What things do we know? Then we're going to substitute those known values for their variables in the equation. So this is where we put these 3 steps together. Okay, now we have an equation with our knowns in it. We're going to solve for the unknown. We need to check for the reasonableness of our answer. If we're measuring segments in centimeters, we shouldn't get an answer that's like 5 and 8 centimeters. We shouldn't get an answer that's 1,000 centimeters. That's probably not going to be reasonable. Okay, and then our final step, write the answer, parentheses, sometimes there's more than one part, to the question, including a variable label. We need to label our answer, and any units if applicable. Okay, if we're given units, we should write units with our answer. What was that?
If you know all this, you have 100%.
If you apply all of it correctly. Yep. Yes, ma'am.
Okay, you said we have to follow step by step, right? If not, we get 25%. But if they don't understand that step by step that you're showing them, and they understand their way, why can't they do it their way?
Geometry is about following a specific procedure and showing every step. So there are specific ways that are proven and justified, and that's what we use in geometry. That is literally what geometry is about. Okay? You will absolutely understand my way if you listen, pay attention, and follow along the examples with me. It's not difficult, it's not hard. But if you're like, well, I can just look at it and see the answer. I don't care. That's great for you. That is not doing geometry. And sometimes we're going to do geometry in simple ways to start so that you can build up to handling the very complex ways of geometry later. And if you skip the simple ways because the answer is obvious to you, then you're going to fail when you get to the more complex geometry because you haven't followed the procedure. You haven't practiced the procedure. Okay? So we're going to start with calculating measures using betweenness of points. This is our basic key concept. Point M in this case. If point M is between P and Q, if and only if they are all collinear. So for betweenness, the 3 lines have to be collinear, and then a 1 point is between the other 2. When this happens, we get a formula. It's basically the whole is equal to the sum of its parts, but you can use betweenness of points. This is our relationship in words for this type of problem. You could use betweenness of points. So here's how this would look solving a problem using betweenness of points. This question asks us to find the measure of AB. I always encourage annotating our diagram. I'm going to mark so I can visually see that part is AB. Now, what is the relationship between these different values in words? This is a point collinear with 2 other points, and it's between them. So this is going to be betweenness of points. Okay. Then what would be the equation for this specific relationship? And our equation will almost never have numbers in it. It's going to be variables or the different parts. So in this case, and I like to think of it in terms of whole equals sum of parts, part 1 plus part 2. Okay, my whole segment here is AC. So I'm going to write AC. That's my whole. Equals the sum of, here's my first part, AB, plus my second part, BC. That's my equation. Notice the equation has an expression on the left, expression on the right, and an equal sign in between. I haven't put in any numbers yet. Okay. Now I'm going to identify and label my known variables. What things do I know? Well, here I know that BC, sorry, these are segments, segment. Forgot my segment. All right, the measure of BC equals 5.8 meters. And I know the measure of AC equals 13.2 meters. That's information. I could get that from the text here, or I can find that from my diagram where different parts are labeled. Okay. Then we're going to take our equation, and each thing we know we're going to fill in. Do I know AC? Yes. So AC becomes 13.2. Do I know AB?
No.
No. So I'm just going to copy that down. AB, I don't know it. I don't know the measure of AB. Plus, do I know BC?
Yes.
BC is given to be 5.8. I'm going to fill in 5.8 meters. This is now an equation with numbers, and it's a one-step equation. What is the one step for that we're going to do to solve for AB? Yes, ma'am.
You subtract 15.2 meters and 5.8 meters.
Okay, so when we're solving equations, we always want to look at it in terms of, here's what I'm trying to get by itself. What is keeping it from being by itself? 5.8. The 5.8. So I'm going to subtract 5.8 from both sides. That's the key for equations, is we're always doing it from or to both sides. So I'm going to subtract my 5.8 from one side of the equal sign and from the other side of the equal sign. So that now on the left, I have 7.4 equals, and on the right, AB is left, and 5.8 minus 5.8 is 0, which goes away, and I have solved for the unknown. Now, is that value reasonable? If I look up here, does it make sense for about 7 to 8? We'll say about 7 plus about 6 to equal about 13.
Yes.
That's a reasonable answer. So that's checking the reasonableness of my answer. And then I'm going to finally write the answer to the question, including a variable label. So when I say the variable label in this case, I'm being asked to find AB. So I'm going to say AB equals 7.4. And all of my information was given in meters. So 13.2 meters minus 5.8 meters is 7.4 meters. Okay. Now, I'm okay if you combine these two steps together, where you have the final answer. You can just box that, check it for reasonableness, make sure you add your label and your units, and you're good. Any questions on this process? It's straightforward. There's steps, but those steps are important because we will be applying them to new things that you cannot just do intuitively later. More? You're getting credit for that because your group was done first. Honey?
So last year she cared quite a bit what the order was. Do you care whether or not AB equals 7.4 meters or vice versa? It doesn't matter.
I like the final answer to always be variable on the left and number on the right. Mm-hmm. Yep. So this was in between, but my final answer should be variable. Where we are putting this in the same way we would say it in words. This means the measure of segment AB equals means is 7.4 meters. So just as we would say the sentence, the measure of segment AB is 7.4 meters, right? As opposed to 7.4 meters is the measure. That's not the way we normally say it.
So then for this specific question, if this were something we had to do, and the 7.4 was the answer, could we skip putting 7.4 equals AB and just put all together?
If it's especially a one step like this and you just want to use it's not transitive property, I forgot. But there's a property that says we can just switch the order. That's fine. All right, good. Okay. One more example of this. Go ahead and I'm going to pause, let you guys try this one on your own, and then we'll go through it together in a moment. All right, we're going to do this one a little bit more quickly now. The relationship in words for finding JL, which I'm going to mark so I know which figure I'm finding, J to L, the whole segment. So this is a betweenness of points. Okay, or the whole equals the sum of the parts. You could write that instead, even though it's in symbols, it's more general than this particular equation. For this problem, my whole is JL, and my first part is JK, and my second part is KL. The things that I know JK is 8 centimeters. The measure of segment JK is 8.4 centimeters. And the measure of segment KL, I know, is 3.9 centimeters. Then I can substitute those in. Do I know JL? No. But I know JK equals 8.4 centimeters plus, and I know KL equals 3.9 centimeters. Now in this case, to solve for my unknown, I already have my unknown by itself. All I need to do now is simplify. JL equals 8.4 plus 3.9, which is 12.3 centimeters. Okay, I have my variable on the left. I have my answer. I have my units. I can actually, in this case, stop right there. Other than I do want to check for the reasonableness of my answer. Yeah, about 8 plus about 4 is going to be about 12. So that makes sense?
I mean, 8 plus 4 is 12, so yeah.
All right, and then we'll pick up with example C. Possibly that's an optional one. It just adds some extra steps. I'll edit that out later.